I want to talk to you about how you can actually use building information modeling, or BIM, to make your fault calculation process go better. Building information modeling is not something that as electrical engineers we necessarily enjoy talking about. It's something that the architects have put together, and they come to us and they say, we want you to use BIM, we want you to do Revit, and we do it because they ask us to. But a lot of times we don't actually see any benefit from using BIM. But there are opportunities, such as fault calculations, where BIM actually can come in and make the processes that we're doing as electrical engineers better and more efficient. There's 4 pieces of interest when doing your fault analysis that I want to talk about. There are the panels themselves and what's connected to each other. There's the feeder lengths between your panels. There's the feeder sizes, and there are any motors that are in your project. So the first one, the panels and their connections to each other. If you're doing building information modeling, that's laying out your panels in your building, that's connecting your panels together. If you're doing that in something like Revit, you have all of those panels, you have all of those connections already made. You want to make sure that you're pulling those connections and those panels directly into whatever you are doing for your fault calculations. Once you have your panels, then you have the distances between those panels. Again, in building information modeling, you are locating those panels in your model, so you know where they are all located. You can use those locations to calculate those distances. To get a true length, you're going to need to model your conduit. You're probably not going to be doing that, particularly in the beginning of your design stages, but just based upon their locations and either doing a straight line calculation or doing some right angles to account for the walls of the building, you can get something that's going to be close enough for a fault analysis. In addition to your feeder lengths, you also have your feeder sizes. The question of where those sizes are set is a little bit tricky. You might be setting that in your building information model if you have a robust enough program that actually has sizes that you can specify and you have good control over. You might just be doing that in your calculation package. So that is a good question of where that information should be set. Then the 4th piece are the motors. Previously, before BIM, motor contributions were, for the most part, ignored for smaller motors because they don't make a big impact. And in terms of modeling in your calculation package, it's kind of tedious to enter all the little motors in your project that aren't going to make a difference anyway. So generally under, say, 50 horsepower, you're not going to be adding those to your fault calculations. Using BIM, that constraint goes away because in BIM, you are placing your motors. You're specifying your load. You're specifying what they're connected to. All of that information is being created because you have to put those pieces in. You have to get them connected. The feeder and service load calcs are going to depend on knowing that that's a motor because you do some diversity and you do demand factors based upon the fact that it's a motor. So you need to know that it's a motor. So those are my thoughts on how you can actually use building information modeling effectively as an electrical engineer, how it can be something that's useful for you in your fault calculations. I hope you can use this information going forward to be a little bit more productive and have a little bit fewer errors when doing your fault calculations.